So if we see this code, the intro is a lot shorter now, right? So the intro is a little bit shorter than what we're used to. So these are the steps though of learning live tooling. The program is generally a little bit shorter than what it is for a OD or an ID, right? Because we're just drilling holes, guys, that's it. Just like I told you guys on Thursday or Wednesday, when I was working at NOV, this is just the program that I brought up, and it drilled holes on the outside of the part. So this saved them a whole milling operation, transferring the part from a lathe to a mill, indicating the hell out of it, making sure it was straight, and then drilling the holes, right? So, as we know, we could write a program on these computers, right? On Notepad. You could go to Notepad, put the % sign at the beginning, right? After that, we need an O and 5 numbers. O, 1, 2, 3, 4, 5. That's fine. If we're gonna do this in real life, we gotta go out there and we have to make sure that there's an empty program number, right? If not, what's gonna happen? It's gonna ask you if you wanna override it, correct? Then it's gonna say Y for yes, N for no, and A for all, correct? Do not push that A. Whatever you do, do not push that A, right? All right, so we have our program number on the top. Now these N lines, I like to put like N1, N2, N3, N4, N5, so on and so forth, right? That way I could find it really easy on my program, correct? So let's say, because normally guys, this is just one operation, right? But like that example that I gave you, that part that I was doing facing, turning OD, OD grooving, drilling, boring, threading, and knurling. 7 operations, right? So just imagine that I'm drilling and I don't have the depth that I want and I need to go deeper. Am I gonna run all 7 operations again? No, right? So then I'm gonna push edit and I'm gonna look for this operation and it's gonna take me a while to find it, right? Because I have 7 different operations. Probably have more because I didn't even include the finishing, right? So I'll probably have about 9 or 10 operations. So at the beginning of each operation, I'll put N1, first operation, facing. Second operation, OD roughing, N2. OD finishing, N3. Does that make sense? So on and so forth. So when I'm in edit, all I have to do is, let's say that the holes are N10. All I have to do is go to edit, and then on the little left, it's gonna be blinking, the little cursor, push N10, down arrow, boom. It goes all the way to it, right? That easy, so you're not looking for it anymore. Does that make sense? All right, so now we have our G00, G53, X0, Y0. We are messing with the Y-axis now, so whenever you're doing live tooling, it would be better if you push Y0, because if you didn't send Y0 back home, it could stay in the same position where it was at before, and it's not gonna drill completely centered. So then we have a G53, Z0. We want to separate these guys. Why?
You want to come down.
Because one's radial, one's axial.
Because our X and Y will just make it go up, right? So if I have a tailstock and I put a Z on there, what can happen?
Crash.
You can hit the tailstock, right? So I want it to go up first and then come back on my Z. Does that make sense?
Yep.
If I have them all together, it's going to find the quickest motion, so it's going to shoot diagonally to home on all 3 axes, right? So I separate them so that X goes home first, and then Z goes home after that, correct? So then I have my tool number. Yes, this has tool 1111. I don't know what it is out there. I forgot. But obviously, if we're running the program out there, we just got to change it to whatever tool station it's on, correct? Okay. Too easy.
Probably.
And then we have an M154. Oh, that's a new code, right?
What?
M154. Code, what does M154 do?
Says engage with C-axis.
Boy,
Read it.
it's on the board, private. Oh, can't even say that, no, never mind. It's on the board, student.
Z-axis.
C-axis is engaged, right? So now your C-axis is engaged. We have to understand that when we're doing live tooling, your spindle is not rotating at RPMs anymore, right? Now your C-axis locks on the brake and it rotates in degrees, right? 0 to 360. Can you go above 360? Yes. 720, 1050, whatever you want, right? But make sure that the hole's lined up to where you need it to on the blueprint. Does that make sense? But that is just activating your C-axis, so your spindle is not going to be training in RPMs anymore, right? So the next line, we have a G00, G54, Z0, C0. So if we left our C-axis in a different degrees, now we're going to take it back to 0, right? That is very important. Why?
'Cause you gotta know which part of the radial needs to be facing towards the tool.
The location of the hole, right?
Yeah.
So if I have a flat here, and I have a hole right in the top center, well, if I don't take it back to 0,
I could just drill it
it's
anyway.
going to be off, right?
Yeah.
It's going to be off. So we need to be precise in this, correct? We need to make sure that that hole is matching up to the feature that it has on the actual blueprint, correct? Because sometimes, like I used that example of the spanner wrenches before. If I put that hole in the wrong location, maybe that spanner wrench is going to hit once it's attached to that pump or that mechanism that it's on, right? And that hole does me no good because now it's hitting instead of having that free motion of where it should be, where it should be. Does that make sense?
Yeah.
So it's not only here that we got to think about, it's where it's going to go on the actual pump, boat, tank, gun, whatever the hell we're making the part for. Spaceship, right? So as long as we match the blueprint, that's the way we cover our butts, right? Because as long as it matches the blueprints, we can say, hey, the engineer signed off on this. This is where they wanted it at. So if you don't like it there, change it, but you still got to pay me, right? They still got to pay you for the work that they did. Now, if you put the holes in the wrong location, do they still have to pay you?
Yeah.
No, right? That's like if you were making a 6-spoke rim, but you only put 5 on there. It ain't gonna fit my car. Why am I gonna buy it? Correct? So make sure we know where that's at. So we got C0, Z0, and there's a G00, right? So at this point, your turret is gonna come up to where the actual end mill is at 0, whether it's type A or type B, right?
That's not a
Like
machine.
I said, guys, it's not a thing. It's not a thing. It's just for you guys to separate. That's it, right? Call it type blue and type red if you want. Type 1 or type 2, I don't care.
Face or center.
But we have so many different stuff out there. Type A and type B was just the easiest that I could think about, right? So we're either gonna touch it off on the face, or we're gonna touch it off in the center of the radius of that end mill, right? All right, now I have an X 3.25. So that X 3.25, what is that movement?
You mean like above it?
I'm getting above my stock, right? Because my stock is only 3 inches, correct? So trust me, guys, why am I asking this question? Because I've seen guys sit on their butts because they saw that it was gonna crash. So what did they do? They stopped it and they went and got the programmer. And then they're like, hey man, the program's wrong. All right, man, I'll get to you after lunch. Okay. So they sit on their butts for an hour until lunch. They go to lunch, they come back, and then the programmer went home because this kid had an emergency. So now what's that machine is gonna do? Well, the programmer wasn't here, so I'm gonna go home too. What happens with the parts? They don't
They
get
get
done.
made.
What happens with the customer?
They get pissed.
Exactly, right? So if I have a 10-inch stock part, that's where I change that number at, right? That approaching, that X value, right? I would change that to X. If I had a 10-inch part, X 10.25. X10 and a half if you want, right? So that's the number that
This
I would
is-
change depending on the stock that
And that's
I
the
have.
clearance above it.
Yeah, that's it.
So like-
Clearance above the stock material.
So when we were drawing an
That's
east spread, that
all.
was just that clearance that
Yep.
moved over, so it's not dragging in
That's,
or on the
that's
car.
all we're doing, guys, right? But see, a lot of people don't realize that dude that had that problem, yeah, you gotta change another number because you gotta change the depth of it, right? But that's all he had to change. You imagine waiting a day and a half? What happens if the next day that programmer's sick and he doesn't come
Yeah,
in?
he's ate bad
He
food
or
at
she
lunch.
doesn't come in, huh?
He's probably ate bad food at lunch.
So what happens if they don't come in the next day and you're waiting on them? So finally he comes in and he just walks over there and is like, man,
I had to do do,
X
do, do.
10.5 and
Enter.
walks away.
Is that really? All I had to do was that?
That's it. But this is the difference, guys, between learning how to read code versus just being a button pusher, right? I've already visited 2 or 3 shops, and even then, the guys that went through these classes, they don't remember it. They don't remember this code. I'm telling you guys, I don't expect you guys to learn it the first day, but I do expect you guys to study it and to retain it, because this is your bread and butter, right? If you're working at a shop and you're asking for a raise, raises don't come anymore just because you spent 6 months here, just because you spent a year here. And then when they do give you a raise, you know how much they're giving you?
Like $1, maybe.
15 cents, 25 cents. I've been to a shop before where they're like, yeah, man, did you get your raise? And I was like, yeah, I got my raise, you got yours? He's like, yeah. How much did you get? He's like, I got 22 cents, bro. Wow. No. And then they asked me, how much did you get? I was like, I got $8. What? But it's the difference of me knowing this, me doing it by myself, me not having to ask the supervisor and wasting their time, versus somebody that's just waiting for, hey, give me a raise because I've been here for 6 months or a year or a year and a half or 2 years. Does that make sense? All right, now that Z negative 0.475.
So now you're going deep.
So now we're going into the part, right? So now
450.
we have to see what the blueprint is asking for to where that whole location is gonna be at, right? I should have made it easier and just put Z negative 0.5. So if I was just going half an inch, now here's where I gotta pay attention to whether I'm gonna use type A or type B, right? So type A is just touching off on the face, correct? Type B is the center of that end mill, right? So, and it also depends what size end mill you're using, correct? Let's just say, for example, so we can make it easier for us to understand. We're using a 1/2 inch end mill, right? And to make this program work, we're gonna go Z minus 400 thousandths, correct? To make this program work, do I gotta touch off on the face of the part or in the center?
Depends how far the center of the hole location is from the face.
Right, so it's supposed to be 450 thousandths.
And you're using a
So,
half?
yeah,
Oh, so then you would measure from the
That'd be,
face.
that'd be from the face.
right?
Yeah.
from the face. This is why I'm saying you gotta read the code to make it match up what you're doing on how you're touching it off, right? And this is an example that I told you guys, it doesn't matter what the programmer says. I could care less. What happens if they tell you, nah man, well you know we always touch off in the center. Okay, roger that. And I touch off in the center. Then it goes 475, but it's supposed to be 450.
And now you're a quarter off.
I'm a quarter too deep, right? I just scrapped my part,
Yeah, quality's not gonna like that.
correct?
Because the programmer didn't know what the hell he was talking about.
And just imagine, guys, I made parts that were 20 inches in diameter, right? About 15 inches long. This is the last operation. I got through threads, and it was Inconel. Got through threads, which, you know, threading an Inconel, it's very tough, right? Then above that, you need to make sure the go and no-go gauge goes in. So just imagine I'm going through all that headache, and then I trust the programmer because I'm tired. I'm tired of making this part all day, touching off my tools, finding jaws, having it sit in there, having the overhead crane just to load up the part. So I'm tired and I take their word. And I end up drilling the holes 1/4 of an inch off towards the face of it, or too deep.
I'm making a different spanner wrench now.
And let's say that material is Inconel. So that material itself costs a few $1,000s of raw stock material.
Oh gosh.
And I just spent all day on there. How pissed do you think that manager is gonna be?
Very.
Right?
I'd quit if I didn't get fired.
And what am I gonna say? Well, the programmer told me to do this. What's the programmer gonna say?
If
No, I
somebody-
didn't. We could easily see right there in the program what it was supposed to be. Why didn't you just do it that way? And you're the one that ran it, so it's your fault. That's what they're gonna say, guys. Why? Because the programmer doesn't want it on them.
That's when you go there and slash his tires.
Right?
Back into the parking lot.
So this is why, guys,
Run 'em off the road.
finding the locations is so important. Does that make sense? This is why I wanted to touch on this as soon as right now. Because just imagine I teach you this in 1 week, and then the next week we have a test. This way you're able to digest it in your mind, let it marinate a little bit, make sense of it, correct? And when we're out to touching off, it's gonna make even more sense because you're gonna be thinking on the back of your head, man, I gotta make sure it matches up with the program too, correct? All right. So after that, we have a what? M133. Ooh, what does that do?
Live tooling, drive forward.
No.
So
starts
it
spinning.
sends a signal to your machine that, hey, I'm about to turn my spindle forward, right? Then the P tells it how many RPMs it's gonna be spinning. Does that make sense? So this is like your S500 M03, for example, right? Because remember, guys, we engaged our C axis, right? So our C isn't moving. So now our actual tool has to be spinning. Does that make sense?
Mm-hmm.
You guys need a little break right now so you can write everything down?
So 134 would be reverse.
Yeah. This is new code, but this is the way it works. Everybody wants to do all the fancy stuff without learning it, right? We have to learn it and then we execute it. All right, so now we need an M98. M98 takes a feet per minute because remember, our tool is spinning, right? Our M is spinning now. So it's just like the milling machine, right? So this is feet per minute. We're no longer in what?
Inches.
Per revolution.
Inches per revolution, right? We're no longer in inches per revolution. Now we're in feet per minute, correct? So obviously, our feet is gonna be what? A
12.
whole number, right? That confuses a lot of people on the lathe, right? Because we're in inches per revolution, we're dealing in thousands, right? 10,000s, 15,000s, 20,000s, what have you. But we have to understand that even though we're on the lathe, we're doing live tooling, and we have to be in inches per minute instead of feet per minute instead of per revolution. All right, so this is a can cycle, pecking. Can we go up there and just drill it line by line, code by code? Yes. But if you have multiple holes, and especially if you're dealing with Inconel, that you just don't want to do one straight shot, that 243 is a lifesaver. You and the damn hose. Put your wife on speakerphone right now and talk about recognizing the hose and drilling. Go ahead, dude.
Very nice, very nice.
Nice hole.
All right.
So good.
So your 243 is going to be your can cycle pecking, right? Now this X, that's the depth that we're going to go to on that hole. Does that make sense? We started at 3.25 and we're taking it down all the way down to X2. So what does that mean?
We're going an inch and a quarter now.
Well, the part is, remember, the part is 3 inches stock.
Yeah, we're off a quarter inch, so we're only going an inch.
Yeah, we're only going an inch on each side, right? Because it's 3 inches stock material, correct? I tell everybody, I sometimes forget hey, is it an inch or is it half an inch, right? Because the thing is, the way that it does it, the center line is at the center of it, right? So theoretically, we're only going half an inch, right? But I tell everybody, especially the first time you do this, and especially since you don't know your machine yet, go above it, right? Because you can always drill down more, but you can't undo and drill less.
You
Does
get a
that make
welder
sense?
to fill it.
Alright,
You ever welded an ink canal before?
you wrote it in canal?
Runs like mud.
But it sucks. And then it's all ugly.
Well, that's the thing, it's, and you gotta take it. But, I mean, it's just, it sucks, yeah.
I mean, hopefully you haven't done the finish pass on your OD and you can clean up the nasty marks that it's gonna look.
A lot of the nuke guys would weld ink canal because that's what the canopy seals for, the nuclear coolant, the water.
Mm-hmm.
That's what they're made out of.
Yeah. See, I didn't even know what Inconel was until I got to machining. Like everything on the ship,
still don't know what
I
it
was
is.
just like,
Submarines especially,
Okay.
or the nuclear power plant.
yeah. I mean,
They all run copper nickel or ink canal.
Yeah, it's got to be strong to hold all that stuff in and everything.
Corrosive resistant.
All right, your Y. Obviously, we want to put it in the center. We're gonna have Y0. But on that Y, you can put it off center, right? So if I wanted it to be a cylinder, but let's say I wanted to drill 2 holes right here, so this can latch onto something like by a U-bolt, then I'll just put Y positive ½ an inch, let it drill, then Y negative ½ an inch, and let it drill that way. Does that make sense? But for right now, our Y is just at the center of it. Alright. Z. Obviously your Z is the same as it was up here. I just put on there for safety measures, right? If you have it there, you want to put in the other one. But it's gonna make the hole wherever the G243 is, right? So I like taking it there first because I like seeing the clearance of it, right? We saw how whenever you're taking the radial tool, how close it could get to the jaws, right? So sometimes, like I said, I've worked with it before where I only had 2 or 3 thousandths before it hit. How do I know? I was feeling foggy one day and I did it and it didn't touch, so then I stopped it and then I put some shims in there. And the 3 thousandths one went in and the 4 thousandths one didn't. That's how much clearance I had.
Mm.
I mean, you couldn't even, I was just waiting for the hit. I couldn't see it. I didn't know if it was gonna hit or not. I was just like, please don't hit. But that's
Wow.
all I had that I could do, right? So that's why I like taking it there first and then making sure that I put it on the actual G243. Does that make sense? And it's good practice, guys, because trust me, when that thing is pecking down and if it hits your jaws, it's nothing pretty. Nothing pretty, because the holder itself is hitting the jaws. So not only is your chuck going this way, your turret is lifting this way too when it starts hitting. Does that make sense? So then you're misaligning here and you're misaligning on your turret. So that's a few $1,000s for that easy mistake, right? C. So it's gonna rotate to 180 and it's from 0, it's gonna rotate to 180. And then R. R is the retract. That R says 4, that's a typo. Obviously, I don't want to go down there 3.25, and then when it starts drilling, it goes up 4 inches, and it starts drilling from 4 inches all the way down, right?
It looks
So
like
that
one of my
C180, if you're
programs.
just drilling one hole, do you have to, I mean, you're just,
You could have made a C180 up here on top if you wanted to.
or you could just drill at 0, right?
Yeah, it will, like I said, it has to match the print,
Right.
whatever it's on, right? If I'm just drilling one hole, that C180, I could have kept it up there and it just wouldn't move.
Because that's
It
what's
would've
turning the
stayed.
lathe piece, right?
Yeah, the
work.
spindle itself. That's holding the wood part, right? So that R, if it was a 3-inch part, I would have it probably like a 3.1, right? Because obviously by the time you're doing holes, you've already done your finish pass on the OD, correct? I wouldn't feel that foggy and put it right at 3 inches, I would put at least 25,000 to 100,000 on top of it.
So basically, just like when it comes
It's
up
coming
and it
up, right,
rotates it
for the
again.
pecking.
You hear him asking a question and you still want to ask him.
So like when it rotates for like the next 180, that's basically how far it comes out before
Yeah.
it so yeah. Okay.
Yeah. So it's gonna come over, it's gonna wrap it to that position, then it's gonna start pecking from there. Then when it's done, it's gonna come up to that 3.1, then it's gonna rotate, then it's gonna start pecking from there.
So you'd be cutting quite a bit of air with 4 inches.
Oh yeah, a lot of air. Alright, that's why I'm saying it's a typo. So that R is your retract. So you wanna make sure that it's within reason, right?
So each peck is coming back up to that R, right?
On this one, cause ours is the initial plane.
So that is a lot of time being spent.
Yeah, if it's 4 inches, yeah,
Mm.
of course. Like I said, that's a typo. But
So
the important thing is learning what it does. And
So
we
it
could
should
do
be-
it both ways.
So you said it should be 3.1, the R?
Anywhere
100.
between, you want it above 3 inches, because obviously
the
you don't want
part.
to scrape it on the part,
Right.
right? If you're good at it, you've been doing it for a while and everything, like I used to put mine like 20,000 or 10,000 above,
Oh, jeez.
because I knew that it was gonna clear, right? But you guys are just starting 100,000s,
Plenty.
y'all could say, because it's only gonna be 50,000 in reality, right?
Yeah,
So that's gonna be enough for it to do that.
okay.
3.1.
Yeah, 3.1 will be a good
3.00.
good measure.
And it'll always go back to 3.1.
Yep.
Gotcha. Then that Q, that 200 that's the depth of how each
Peck
peck
increment.
goes
Yeah, your peck
until it
increment.
gets to the bottom.
So that's your peck increment, guys. So obviously, in real life, if we're doing this, what are some problems that we could run into? Junior?
Managers, programmers.
Build up shavings and chips, right?
Oh, yeah.
So if I'm only going 20,000 above the part, is that enough room for the chips to come out? Well, it depends on the material, right? Depends what type of tool I'm using, correct? But if I have coolant shooting in there and I come up 100,000s, that should be enough for it to come out, right? What else is another problem that I can come into?
With that pecking height.
Yeah, that has to do with like the pecking mill. I can break my damn end mill, right?
Yeah,
If I break my end mill, what's one thing I'm gonna look at?
that's gonna get stuck in there.
My pecking,
Dude, that shit
right?
gets stuck in there.
If I'm pecking too much, maybe I ought to adjust my cue, right? If my manager's like, hey man, I need you to knock these out faster. Obviously going faster, you're gonna get wear and tear on your equipment a lot quicker, right? So what are you gonna tell them? Hey man, if I take that cue to 300,000 or 500,000, this end mill's only gonna last like one part, and that's it.
You better
right?
run like 8 end mills every year.
And so he might be like, hey, we got extra end mills, but this job needs to go out by the end of the day. Do it. Roger that. You're paying for the tools, I'm not. So,
That, don't they equate in there the time it takes you to change out that end mill?
well, they don't.
They don't
Sometimes
care.
they
That
don't
would
care.
suck ass.
Because
Do that.
whatever
Yeah,
makes it
that's-
done faster,
Now that slows you down.
that's what they're
though.
worried about, right?
Slow, smooth, smooth,
Because
fast.
you guys gotta understand that if you guys have a contract with the company and y'all have already been late 2 or 3 times, right? And they tell you, hey, if this one's late, we're not gonna do business with you no more. I used to work with companies like the job shops that I worked at. They had contracts with other companies. Every quarter, they gave us like $750,000 worth of work. So you're talking about $750,000 every quarter, right?
That's
You think I'm
$3
gonna be
million a year.
worried about breaking end mills?
At $3 million a year?
Hell no. I'm gonna be like, hey, order more end mills, bro.
That is pocket
Let's
change.
go.
That is pocket change at that point.
That's just a drop in the bucket, right? Those end mills probably run what, $50 a piece, if that?
Then you probably get really good and really fast at changing end mills.
I mean, I'm touching off. Because when you change them, you still gotta touch them off, right?
Yeah, your H.
You still have to touch them off, so it's at the right depth, correct? So all this comes into play, guys. Like I said, you guys gotta think like managers whenever you're working there. You can't just think about the problem at hand. Yeah, why is this guy asking me to run it fast? Once he gives you your blessing, okay, let's go. Like I told you guys, I ran a big lathe before, and the whole ground would be shaking when it was turning to OD. I had to put on earplugs, and just to sit there and watch it. Everybody walking by like, hey man, what the?
quarter-inch thick chips.
They'll be like, why don't you slow it down? Why don't you? And man, the boss wants it this way. It's his machine. That's what I'm gonna. All right, man. And then people like in the machines next to you, they'll be like, put them on their earplugs and everything. Oh well, that's what they. As long as you get their like signature or their initials on a piece of paper, they ask for it, right? And obviously, if they're a manager, the owner put them as a manager for a reason. So if that machine breaks, hopefully it breaks on the last part and you finish that part. And then you'll be like, all right, man, I'm done. It's smoking. It's broken. It's crashed. Call the repair guys. I'll see you tomorrow. You did your job, all right? But you probably saved a contract of $750,000 every quarter, right? So that's the important thing. So when they ask you to do something, don't get your feelings hurt. I gotta watch what I say again. Don't get your feelings hurt and just be like, roger that. If that's what you want, go. I'm gonna run on this paper on my blueprint on the backside. Hey, manager told me to run it as fast as possible, whatever. And man, you don't mind, just put your initials there. He's gonna be like, I don't give a shit. I asked you to do it anyways. Here you go. Boom, run it. Roger that. Let's go. So anything else that happens, it's on them. And then your F is obviously your
Feed rate.
actual feed rate, right? So now, like we said, this is a can cycle, right? So guess what's cool about this program? If I wanted 4 holes, and I put C0 up there and C0 here, under here, I'd have to do is put C90, C180, and C270. Now, that only works if they're all at the same depth, because they're all gonna follow the depth that you set. So it has to be the same size of hole, 1/2 inch, 1 inch, whatever the hell you're doing, and they all have to be at the same depth.
So you don't have to write that whole line over again, you just, after that line,
It's a
you
can
have
cycle.
C.
Yeah. It's just like the mill if we're drilling a hole, right? And we're using a G81 can cycle. For the next location, what do we have to do? We just put the coordinates.
It'd be different if you had like,
Just with the coordinates.
you would have to put like angles of each one. If you had one on the top and then the next 60 degrees you had one, and then like say you
Well, it's
had
just gonna
another
spin
one the
apart.
next 30 degrees, right? You'd have to step by step it like that. You wouldn't be doing a can cycle for that.
If they're the same depth and the same
Yeah.
size hole, I would.
Okay.
So after
Because
that,
you could put any degrees you want on there, right?
Okay, I see what you mean, because you can just put a C under that and it's
Yeah,
gonna keep
if
doing
it's
the
30
same
degrees, I
depth.
could put C 30 degrees. If it's 45 degrees, I could put C 45 degrees. As long as the drill size, the end mill is, or the drill is the same one, and as long as your depth is the same depth, I could put whatever degrees up there I want and it's gonna do it.
so after that G43 line, my bad.
I feel like this is like, let's count from front to rear. Count off.
And then everybody says the same thing.
1, 2, 3, 3, 3.
So-
Damn it.
What's telling the spindle speed, how fast to turn
Rapid.
it? Okay. So just whatever.
25%, 25%, 50%, or 100%. That's when it rotates to the next degrees.
So under that G243, the long line, when you finish your F12 and you go to the next line down, all you have to put in is the C in whatever position. You don't have to write out a whole 43 all over again.
Like I said, if it's the same depth, and it's the same size hole, you just gotta put your next degrees.
All right. So if we had 12 different holes, so you would have 11 lines after that with C15, C38, C24,
Yeah.
whatever.
Now, this is the important thing about the C. You need to put a decimal point on there.
At the end.
Yeah, so if it's C30, you need to put C30
Period.
decimal point.
Okay.
What type
If
of
you don't do that, guess what happens?
red?
You go C30 thousandths.
Oh. So no alarm.
So it barely moved.
Not an alarm,
Barely.
just crack your part. It's gonna do that hole.
I'd rather have the alarm.
Yeah, well, I mean, the alarm would be safer,
Running graphics.
but, no, because graphics sucks with live tooling. You can't really see. Like, I mean, and then they
Clicking on
sit
it,
there
so
and
we
it'll be
click on it.
advertisements and they sit there and read them.
No.
I don't like this.
Are you even thinking about getting this? No, but I want to see what's available. What?
You bought it because it's on sale. And you don't even have period.
When's Black Friday?
Day after Thanksgiving?
February, no. Wait, I'm sleeping. Don't.
Bro, November.
Yeah, it's about
November.
this. It's getting ready for Christmas.
It's
I'm
the
gonna
day
buy a
after
brand new
Thanksgiving.
monitor.
It's the Friday after the Thursday Thanksgiving.
Okay. Let's see what Amazon has this year.
Yeah, but sometimes they'll run it all weekend, or
Cyber
even try to go
Mondays,
early,
maybe.
like the week of,
Yeah.
or they'll run it over the weekend, or even for a whole week after.
Yeah,
Cyber
like
Monday.
that. Like we only come to school for Thanksgiving weekend. We come Monday and Tuesday.
Yeah,
I
that
don't know
sucks.
why.
It's fucking. Because Lone Star's retarded.
We come in Monday and Tuesday.
You come on
Alright?
Columbus Day when everybody in the freaking world's out.
So Monday and Tuesday we come in, but luckily we have. There's a lot of shops that don't even have Wednesday off. Like since Thanksgiving's Thursday.
I'm surprised we have Thursday off.
Yeah, they only have Thursday and Friday off, but we actually have Wednesday off. I don't know if Junior does. I don't think so. Your dad has work. day.
Friday off?
You'll be working Thanksgiving. Oh, you going to Mexico? Okay. All right. So, like we said, once you
Listen.
put your C's on there,
It's all right, I got notes for you Monday, Tuesday.
make
Okay.
sure that you have a decimal point on there, right? Make sure. I've seen people do this in their test, and they're all confident, and I'm like, are you sure? Yeah, it looks good. Are you positive? Yeah. Are you sure? Yes.
The decimal point?
What happens if they miss a decimal point?
30,000.
Scrap.
50.
So you're
That
talking
little
the
period
coordinates
might
for the
be half
decimals. You're talking about the regular coordinate system. So 0 would be on the
Yeah,
right
so
hand side.
C0 would be right at the center, right?
Right.
If I put C90,
Okay.
it'd make this one.
Okay.
C180 would be down here.
So if you go from C0 to 180, it's making it top and bottom.
Top and bottom. Remember, it's just a blueprint reading class, right?
Mhm.
Where 0 starts here and then it's 360,
Right.
right? That's all it is, right? So that's how you can reference whenever you have flats somewhere, or a hexagon or pentagon or whatever, right? Because we have a pentagon and we have one straight at the top, well, we gotta know how to write a program for the pentagon and have the hole on the top of it. Does that make sense? So that comes into play big time. We need to make sure where that whole location is gonna be. And like I said, all we need to do multiple holes is see at the bottom. But just like I said, you miss one decimal point, what's gonna happen?
Okay.
If I have C0 here, then C90, and I forget my decimal point, I got another hole right here.
There were 90s at the 12 o'clock.
Yeah, it would be at 12. So well, it would rotate over here, right? Let's just say, theoretically, right? Let's say this was 0. So if I put
Yeah.
C90 and it want to make this one,
Counterclockwise.
it would just make C90 thousandths and they'll drill on there. But then I did put C180 point, and then I'll have another hole over here, but this hole would be obsolete, and I would have 2 side by side. Would you buy that part if you needed to install it in your vehicle?
No.
It's not gonna fit. So, you would get a 50.
In a cool car part.
You know, paperweight.
So, this is why, guys, it is so important to pay attention to detail. It is so important to make sure that everything in that program is there. Normally, if I say, are you sure? It's not because I want to trick you, it's because I saw something wrong and I'm just like,
He's tricking us.
look at it and make sure that that's what you want to do. Because just imagine that you wrote that program and you thought everything was right, and you made that part that's Inconel that the raw material cost, it's $8,000.
For an inch.
Huh?
For 1 inch.
It costs $8,000 for that raw material, and you ended up making that mistake. How are you gonna explain that to your boss? I don't know what half of y'all would do.
I wasn't here today.
Damn machine broke.
Half of y'all would go ahead and put that decimal point on there and be like, I don't know why I did that. Look, the decimal point's right there. I know better than that, right? I know better than that. Just say, there's no way in hell.
I blame the programmer.
There's no
and
way.
then
There's the
threatened to take his
machine.
job.
The damn end mill did it. Stupid CNC.
And Mel stuck his hand,
The
opened the
freaking
door.
the AIs took over. Alright, so after I do whatever holes that I want, after I do the holes that I want, I just come back up to X positive 5, right? So it can go above the part,
And
just for
beyond.
clearance, right? Then I'm just gonna hit Y0. It's just a good habit, guys, because if you did drill on the sides of it, you want Y to be 0 again. Did I show you guys Y on the actual machine? How it runs with X when it goes up and down?
No.
Alright, so I'll show you guys that whenever we go. Alright. And then your M135
Stops the live
stops your
spin.
actual live tooling, right? It stops spinning when you have that M135 on there. M155 disengages that brake on the C-axis. So now once you finish that part, you put another part in, it's not gonna be thinking that the C is activated, it's gonna turn in RPMs. Right? And then after that, I'm just gonna send my machine home on G00, G53, X0, Y0, G00, G53, Z0, right? Or just G53, Z0, because it was already on G00.
So this is what our second test will be, is touching off and then doing
This is half of your second test.
It
Oh, we'll have to
seems-
still profile and, or do OD and face. Where
Well,
and
since
then
you
do-
asked that, you're still gonna have to face, turn OD grooves, OD
Damn it,
threading, drilling, and then ID.
ID and canal. And then you gotta attach positive to
I'll
it.
take the 50 now.
So, no, your test should be either radial drilling holes or axial drilling holes, and then doing flats either radial or doing flats axial. Whichever one the instructor feels more comfortable of the class doing. Does that make sense? So, when summer times when this class is a lot shorter, and especially that class that there was one summer that we missed a lot of days too, not just your classes, but there was one. I just made them do holes in the front and then flats on the top, just because it was easier to do it that way, right? So it all depends on how much you guys are learning and how far y'all get. Because the concept is there, and we're gonna teach you the concepts of it, but you actually doing it, yeah, sometimes it's harder doing it this way or doing it that way, but if it's comfortable in the class and everything, we'll just take it that way, right? So, how many of you guys are happy that we actually went over the G-code today?
So would there
Versus
be
just
one
the-
more line for the Z0?
Yeah,
Yeah.
like I said, G53 Z0 PowerPoint.
Well, now we can go out there and touch off and do G-Code.
You can.
So-
I mean, there's nothing stopping us from doing that, right? Like I said, guys, you can do whatever you want on these machines as long as you know how to do it. That's it. Sometimes there's stuff that I get a blueprint and I'm like, how the hell am I gonna do that? But then I look at it and I'm like, oh, well, I could do this and I could do that and I could do this too, and that would work. And then I just combine 2 or 3 things together, and then it ends up
I'll just
working.
pull
Take
up
it
one
to the
over
grinder.
it's already in there.
Huh?
You gotta know what order you gotta do it in.
Take it to the grinder,
Of course.
get that shape.
More than touch it. You got to, like I said, guys, once you learn that machining is the same operations over and over again. That's it.
Repetition.
We're gonna do facing. You know you're gonna do facing no matter what, right? You know you're gonna turn your OD no matter what. Given that's bare minimum. Facing and turning OD, right? Making chamfers, correct? Because you don't want any sharp parts. The sharp edges on the parts, right? After that, drilling, G83s, simple, right? ID boring, we already know how to do that. How many of you guys remember G71s and G72s?
I heard the term
You can write a
before.
program right now, no problem.
I heard that somewhere before.
Probably like in June.
Y'all wanna go over that again real quick?
Might as well. It's like free education. I was gonna say no.
It's like free education. You paid for it. One way or another. With your blood, sweat, and tears when you were overseas, you paid for it. Alright, let me find my G71 and G72.
Cuts on the Z, cuts on that.
Nah. That's what I was looking for.
G71, P10, Q20, U.
There it is. Someone emailed it to you.
Man.
There we go. Cross programming manual. Find G71 and G72. There we go. 71. Aye. One, yeah, 72. There's 72. Oh, you can use that search function too in here.
No, yeah, but I was looking at the different examples.
Oh.
Trying to pick which one would be the best one. Because unless you guys want to spend like a lot of time on it.
I still got the notes for
June.
Screw June. Screw June.
So, the G71 is what gets everybody. G72 is just the facing. We know that with the G72, the intro is the same, right? But, so on the facing one, the intro is the same, but that Z value is how much stock we have in front of that face, right? That's what we will switch if we have 1/2 inch or whatever, correct? And then we have our RPMs, that would be a G72, the P has to match the N, the Q has to match where we finish, correct? And then we have our U, W, usually for the facing, that would be 0, then your depth of cut, right? So then over here for the N10, we would have a G00, Z0, because that's what we're gonna get to, correct? G00, Z0, then under that we have a G01, X negative 62 thousandths because we're facing off the 62 thousandths, correct? And then we have a Z.25 or Z.1 to come off the face. And on that line, we'll have our last, whatever we put for our Q. If it was Q20, we'll have N20 on that line, and then we'll just send it home, right? Too easy. And we could practice it when we're out there again, right? We could put a new part in there, we could do a facing program, then we could do a turning program, and that'll be our start for this class, correct? Now, what I wanted to go through more though is your G71. Remember guys, a lot of people get confused because your facing comes before your turning OD, right? So everybody thinks that a G71 is what? Your facing, right?
Mm-hmm.
And everybody thinks a G72 is the turning OD, right? How many of you guys messed that up when you were out there practicing or did your test? You're a little confused, right? And what did it do? It threw an alarm at you, right? And it said, hey, I'm not designed to cut that way, correct?
It's too long.
Because your G72 cuts along which axis?
Z.
The 72 facing. X-axis, right? It's cutting down, right?
Mm.
And your G71 is cutting along
Z.
your Z-axis,
Yeah,
correct?
that's what I said.
So just remember that they're flipped. As the way you're thinking it, just say, hey, they're really flipped, right? Now, like we said before, your G71 can be used for OD and ID, right? So if we're boring jaws, we could use a G71 all day long, correct? All right, so let's go down to this program. So obviously we have our percent sign, we have our program number, right? Then we have a G28. What does a G28 do?
Home.
Sends everything home, correct? G50, what does a G50 do, girl? What's a G50? You work at a shop.
It's your lad.
Oh. Yeah, push brooms.
Junior's like, hold on, man. Let me look at my notes because I forgot. What does it do, Junior? What's a G50?
It's like activate my.
Some of it's got a spinner speed of
powers.
1750, so it's got to be.
Activates 102 powers.
That's got to be the check speed.
What is it, Gannon?
Is it max spindle?
Maximum RPMs, right? It won't let your RPMs go higher than whatever you set it. So in this example, we said S to 1750, right? So our RPMs won't go higher than that. So obviously when you push the button, nothing's gonna happen, correct? Because you're just telling it that information. You're just letting it know, hey, whenever you reach these RPMs, don't go higher than that. That's it, right? Little things, guys, we gotta remember also, right? Those little things. Then we have a G97, S320 MZ03. What's a G97?
Constant. RPM.
Constant surface speed, correct? So it's gonna have the RPMs spinning at the same RPMs, no matter how close you get to the spindle line or above it, correct? They're gonna keep on rotating the same. And then it has, usually you wanna start with the low RPM on this one, S320, S500, then it activates your MO3, right? Which turns your spindle to a certain direction. Like we said, usually we use this as a safety protocol, right? Because if my part's gonna fall off my jaws, I want it to fall off while my turret is still far away, correct? All right, then we have a G54, G00, X3, Z.1. What is this line?
Part approach.
Rapid.
It approaches the part, but it is also what?
0.1 above it.
But what is that line also identifying?
Oh, your WCS work coordinates?
Work coordinate.
Stock material,
Oh,
Yeah.
right? So it's the start that's identifying your stock material. Because if I don't put it up there, how does my machine know, hey, start cutting here, whatever depth of cut you're telling it to, right? So if the guy that orders the material messed up, and these parts are only 3 inches, but they accidentally ordered 4-inch material, and the manager's like, man, I know we're gonna lose a whole inch, but run it anyways. What are we gonna do? We're just gonna change that X value to 4.
Sure.
4.1 is what I
Yeah.
would actually do, but about 4 inches, correct?
So you're 3 inches above it, 1/100,000ths in front of it.
Yeah, but like I said, that's the start
Okay.
position of you doing your can cycle, right? So that part is important. It's not just you approaching to the part. That's saying, since this is this is 2.8, so it's starting right here. That's how it knows, hey, start here, then start cutting, right? If I ended up putting X2, well, it would start here, and then it would throw an alarm because it's saying, hey, your geometry is above that 2. That's not gonna jive, right? It needs to be above your stock material. Does that make sense? So that's why that's starting right there. So that line is very important, right? So then we have our coolant on, then we have a G96 S300, right? So this one, the way they word it, guys, I hate it, because this one is constant surface speed.
Kind of like ramp speed.
Yeah, it's constant surface speed. It should have said, hey, G97, RPM stays the same. G96 gets faster while it approaches the middle of the spindle. That's why it should be identified. But it's constant surface speed. So when I hear the word constant, I think the RPMs are constantly spinning at the same RPMs, right? But no, it's talking about the surface finish. So the finish is gonna be cleaned constantly all the way down. And how does the machine achieve that? By raising up the RPMs the closer the tool gets to the center of the part. Does that make sense? All right. So then we have our G71, right? Which is cutting along which axis? Z.
Z.
Right? G71 is cutting along our Z axis, right? So then we have our P and the Q. P is the start of our geometry, right? Q is the end of your geometry. But just as we mentioned in the other class, that P has to play with that N. So it has to be the same one, right? And that Q has to be the same as the last one, right? At the end of your geometry. Now, like we said it before, guys, these Haas machines, if you have a P10 and a Q20 on your facing and your turning OD, it's gonna throw an alarm. Because it's not gonna know which one you're referring to, right?
That's the
Now,
one that Paul had.
if you do that on a Mazak, Mazak's smart enough to separate them, right? But just by rule of thumb, guys, I would go ahead and separate them. I mean, there's enough numbers out there in the world, right? So, and like I said, I like to name my programs N1, N2, N3, N4, right? So usually I start mine off like a P100, N100, Q200, PN200. Next operation, jump another 100, right? And 400 and 500, correct? So that way, you're just jumping hundreds, because it's gonna be rare that you have more than 100 operations on that part. If you got more than 100 operations, you better be getting paid very good if you're doing that much on one part.
Making like a quantum particle accelerator part or some shit.
Yeah, so, U does what?
How much material is on
Which axis? X-axis, right? So how much you will leave on your X-axis for a finished pass, correct? So in this example, it's gonna be 20 thousandths. So what does W do, Cup?
Y-axis.
Your Z-axis, right? How much material you're gonna leave off on the face of each part? So how much material I'll be leaving out? Will be remaining here and here, basically in this example, right? So I'm leaving 10 thousandths. That the finishing pass is gonna clean up 10 thousandths here, 10 thousandths there, and 10 thousandths there.
So after it roughs it all out, it'll come back and just.
Yeah,
trim
for a
all
finished pass. Yeah. Whenever you're doing anything that's like precise, you need to have a finished pass.
Tolerance.
Yeah. If you have plus or minus 30, you don't need a freaking finished pass. I mean, that's 18 football fields. But if you're messing with plus 2 minus 0, yeah. Especially if it's Inconel, you would rather change out your roughing tool than change out your finishing tool. Because once
Right.
your finishing tool is set,
Yeah.
it should continue.
Point to your insert.
Yeah. Alright. So then we have our D. What does our D value do, Corey?
Drill. No, drill. Depth.
Depth of cut, right? So each time, if I have 100 thousandths there, it's really gonna be taking off 200 thousandths of material. Does that make sense? So that comes into play, like we're dealing with Inconel, right? If I'm used to putting D1 there, but I got an Inconel part in there and I'm taking off 200 thousandths out of pass, maybe I wanna drop that to D50, right? So I only take off 100 thousandths.
Why is it double?
Right? Trust me, guys, I've made parts before that each roughing pass, I had to switch the tip to another tip. So it would just rough one time. Come back up, come forward, stop, turn off the coolant, open the doors,
Allen
take off the inserts, yep, get the Allen wrenches, flip it, tighten it up, close the doors, turn on the coolant, does another pass, comes up, comes over, stop, turn off the coolant. Every single pass.
How many passes is that?
Oh, I had about 15
So why is
passes.
that depth of cut? Why is it double?
This is,
Like-
a half.
Because of diametric, yeah, because going towards it, the line, center line.
See, I would have forgotten that if we wouldn't have gone over that.
And you could test out that theory again when we're out there. It's a
Oh.
lot of people understand it more when you actually see it and then measure it, versus me just telling them. But let me just show you. Look at the machine. Actually, then measure it again. Then you got it. Because remember, it's from the center line. X1, it's really X.5,
Gotcha. Yeah.
right?
And then the
Because
other
it's at
half
least
on
1
the
inch
bottom.
of
Yeah.
material. Yeah, top and the bottom. But yeah, I had to do, because with the aching up part, if I would have let that insert there, and they would have done 2 passes, before it finished halfway of the second pass, the whole insert would have shattered. So I just lost whatever sides I had left.
Wouldn't that fuck up your finish? Right, well, not really, no.
Depending how close you are to your finish. If it was like your second to last pass, then yeah, it would mess it up, depending on how deep that gouge would be. But if you're still off a ways, you should be okay. But obviously, if you just put that insert in there, you have typically what, 4 sides, right? 1, 2, 3, 4, correct? So if I just put that insert in there, it should last me 4 passes. But if I was feeling froggy and I let it run once and I'm like, oh, it's a brand new insert, let it run again, and it got halfway and it broke, well, I just lost 3 other sides that I could have used, right? Then I have to, hopefully, I'm able to take off that insert and put another one in while it's still in that position. But if I had to push reset, what happens?
It's gonna air cut the rest of the.
I have to restart that program all over again. So everything that I cut already is just gonna cut the air, waste more time. Does that make sense? So we have to make sure that, especially when dealing with Inconel, you're able to identify the inserts and how long it's gonna last you.
You couldn't skip that though? Like in the program, just like move past all that and go to where you need to and just run the program from
Because
there?
think about it, all this information is useful.
Oh.
You're telling it the tool number, right?
Like it wouldn't remember all that?
No, because once you hit reset, you clear it out completely. Yeah, you can't just jump down here.
Yeah, okay.
Because you miss all of this other identifying the tool. Your
But then you
RPM.
can run it at 100% because you ain't cutting air, so.
Yeah, I mean, when you're cutting air, you can turn up your feed rate as much as you want until before you're cutting.
And then you would just sort of
Alright.
pause it
Yeah.
and then slow it down and then.
Yeah, I mean, like you could run it at, you could jump your feed, beep, 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 beep. Maybe go like 500. And before it actually cuts,
Then
just
slow
drop it
back
down to
down.
100 again.
Yeah.
And then it started cutting, right?
Okay.
Now, if they pissed you off at work, just let it cut air, bro. You can just sit there.
You're getting
You
paid
know,
by
what are
the
they
hour.
gonna do? The light's still green, there's coolant going, there's the
Chiller
RPMs are turning, it looks like you're cutting it. What are they gonna tell you? Yeah, they can't say anything, right?
What are you doing? Working?
So after that, like I said, we have our N10, right? The P has to match up with that N10. Then we have a G42. What's a G42?
Cut.
Cut it comp what?
Left.
Up, top, down, bottom, left, right.
Left. Let's
360.
get him. To the left, to the
If
left.
it's cutting right here, it's open on the right, right? So it's cut a comp right.
Yeah, I told you.
The OD is gonna be, you said left, you're the only one that said left. If we drilled a hole and we were going to ID, that would be cut a comp left. Does that make sense? So if we're doing ID work, it's cut a comp left. If we're doing OD work, it's cut a comp right. Alright?
G41 is to the left and G42 to the right.
You should know this already, bro. You work at a shop. Don't you run a lathe? You sound like you're asking me. You gotta tell me, no, mofo. G42 is to the right, because I know it, and I know I'm right. Alright, then we got a rapid movement, right? G00, X 0.5, correct? So where did I get that 0.5 from? Yeah, these numbers are horrible.
Can't see shit. You're asking right below the, where it's the,
You guys, I should have had you put it up on your screen so y'all could zoom in.
might be that time to go to the eye doctor.
Where's it? What line are we looking at?
Shit.
G00, X05?
Why is it X.5?
Because you're going up half an inch. Damn, he's good.
As bad as I hate your word.
Hey, we them boys. We them boys.
Remember guys, whenever we start doing the chamfer, we want to start under the chamfer, then come up, then do the chamfer, right?
Yes, yeah.
If I'm up in front of the chamfer and I come in and I just start doing that chamfer, that little piece of material in the front is gonna fold over and it's gonna leave like a little sharp edge, right? But if I start under it, then do that chamfer, I don't even have to deburr it or nothing,
I remember that now.
right?
Coming up, like right next to it and then.
Yeah, you don't wanna deburr, you don't wanna sit there and do something that the machine could do for you, right? So many times I've seen people in shops, like after they run the part, they open the door, turn on the spindle, and they hit it with the file or with sandpaper. And it's like, what the hell are you doing? Oh, I'm taking off the sharp edge. what? And then I look at the program, and I just insert 2 lines, so it starts at the bottom, then it goes into it. Oh, look, bro, cool, I don't have to do it no more. Let the machine work for you, right? Let the machine work for you, right? All right, so this is, I want to say 0.8. That's what it looks like to me.
Looks like a fucking scribble.
Is it 0.8?
I can't even tell what
Alright.
it is, dude.
So that's 0.8.
It looks like X and then.
This is 100 thousandths, right? So 100 on the top, 100 on the bottom, that's 0.6, right? So they're starting 100 thousandths under that. Does that make sense? That's why they started at X.5. You tracking? And listen, I should give you a test on this. First day of class, right?
And you messed up.
How many guys would have passed? Junior, you think you got it?
Mission failed.
20 minutes on the machine?
Alright, what am I doing? I have this.
Alright. So then after that, we have our G01. G01 is what? Oh, my daughters even know this.
Linear.
Linear cut, right? Now we're gonna start cutting, correct? Into the part. We're not rapid anymore, because if we were setting rapid, boom, we would have crashed into the machine, right? So, well, now we have a G01, Z0, so we come to the face of the part, right? Because we were 100 thousandths in front of the part, right? Because that was our last Z. So we were over here. Now we have our G01, X, the X is at 0.5, so it comes to the face of the part, correct? And obviously if you have a G01, you need to have a what?
Tool?
Huh?
Tool?
Feed rate, right? We need to have a feed rate on there. And this is inches per revolution, so our feed rate is F.012, right? Same thing as we had up here on the G01.
There we go. That says 0.8. I got it drawn up.
It'll keep that until you
Oh.
change it for the next one, right?
Yeah, unless you switch to F, it's gonna remain the F throughout the whole program.
Oh, now you come back after
Sometimes
part
that-
questions?
Some of the reasons why you might wanna change it is because, let's say you're doing Inconel, and you have a radius, and it keeps on breaking the insert when it's on that radius because it's taking too much of a depth cut.
So,
And it's going under the material, right? Right before that radius, you will slow it down to like F6, so when it's done from that radius, you pick it back up, right? Those are some of the reasons why you would wanna change your feed rate under your geometry. Does that make sense? Alright.
Oh, it is 8. One less.
So, after that, we're gonna come up to X.6. So that's gonna be right there, right? So this is 0.8 minus 100 thousandths minus 100 thousandths. That's the start of my chamfer, correct? So we're at the very start of the chamfer. And then we're gonna go to X.8, which is this OD, Z minus 0.1, since it's a 45-degree angle, right? That made it easy for you. That's 0.1 coming back, right? 100 thousandths and 100 thousandths back, so it's, your Z is negative 0.1. And they dropped down the feed rate to 8 right there. So now we are right here. Does that make sense? So then we have a Z minus 0.5. So this is Z negative 1.5. So obviously there's a little radius right here, R.5. That should be there. Probably not in your book, but it should be there. Does that make sense? So Z minus 0.5. Then we have a G02. So,
Yeah, it does have a radius there on the right.
So, clockwise.
no. That was 100 thousandths.
Yeah,
It's 100 thousandths radius. So right here,
That's what,
Go to the picture.
I thought that was it.
Yeah.
this does say
G02.
1.5, right?
Yeah,
Yeah.
but you're starting at 1. That curve starts at 1. It's that.
One further, it's 1 inch, or are you talking about inch?
This little thing?
That's not making sense.
Yeah.
Well, you
That's
also
maybe a
said don't
half-inch
trust
radius.
this manual either, because there's a lot of misprints in this thing.
Is that a 1/2 inch radius?
No, it's, the way that this code is, it should only be 0.1. Yeah, it's 0.1.
Is that what the I is right there?
Yeah, because that X is 1.5. That's what was throwing me off. But, all right, so from here to here, it should be
That's the finish of it.
0.6
Yeah.
from here to here.
Well, there's a line right there. It just doesn't point up to it. Look at that Z neg 0.6.
So that 0.6 should be right here,
Yeah.
right? So it comes back to Z minus 0.5, which is right here, right? Then we're gonna go to X 1.0. So 0.8 plus 0.1 plus 0.1, that takes us to X1, right? That Z now turns into Z negative 0.6. And then if we look at the center of the arc, the start to the center, we're moving up on an x-axis, right? So that's why it's an I. So I.1.
Can you
Or
just-
you could have a R.
Okay, I was about to say.
Yeah, because I thought I plays a vote.
Yeah. So the R what? Is that what you just said?
Yep. Yep.
So I plays with R, yeah.
Sure does.
And then so does K.
Why not just
You just need to have the R.
why not just make it easy and just put R?
They're being difficult here.
Because
Why'd you
the
get married?
it's Haas,
You
man.
want to make your life difficult, right?
I mean,
So
yes.
it's the same thing over
Join
here.
the military then.
So R.1, right? So just don't get married, Jimmy. Don't get married. Don't do that. Don't get married. Alright? So now we have a G01 X 1.5. So that's that 1.5. So we come up straight right here, right? So then we have we're still under a G01 because it's an
Okay, I was wondering where that
angle
G03
cut,
was.
right? It's still an angle cut, so it's gonna go diagonally, right? So that X is gonna be 2 inches, and my Z is gonna be negative 0.87, 0.850. Says it right there. So that takes me to there. Does that make sense? So after that, my Z is negative 1.6, just goes there, right? And then that radius, it's not defined, but let's just do the math that it's given us so we can figure it out.
Hey, you should like hit the plus sign next to the 80.
So it's 25 thousandths.
250 thousandths.
Or sorry,
0.250.
Man,
my brain's not working.
So we're going to X, Z minus 1.6. What's this X, the total X? It should be 2.8? Yeah. So then they're coming up to X 2.3. So the radius should be 250, right? So 250 minus 2.8 is 2.3. So then it comes down, up, but we can't see it, so it comes over here to X 2.3. Then we have a G03 because it's going from here to over there, right?
Radius.
So that's our 3 o'clock to 12 o'clock, right?
Yeah.
And then so it's gonna finish up at X 2.8. Z is gonna be 250 plus this 1.6, right? So Z is negative 1.850, correct? Or it's gonna end up on this line. And then our K, because the start of that to the end of it, it's gonna be on from here to there.
Negative quarter.
It's gonna be on the Z-axis, so that's why that K is negative 250. Remember, when you use I and K, it's incremental, right? So you're gonna have negative signs on there. When you use R, it's not gonna be a negative, it's just gonna be R, whatever on there, correct?
Use R.
Just use R.
Yeah,
And
just
then
use R.
G01, Z minus
I
2.1, we're just going past the part.
Let's go cut.
Then we have an N20 that
End of
we're
code.
done with it, right? Remember, without the N20, the shit's not gonna work. I mean, the program is not gonna be effective, right? So we need to make sure that we put an N20 because it has to play with the Q. If you don't have an N, it's not gonna register it, so it's gonna give an alarm up here, even though your fault is way down here.
He did
Does
some
that make
shit.
sense?
Yeah, then you're like, ooh.
Yeah, then you're gonna be thinking,
That's
and
military.
everybody
Such a
knows
word.
how Haas does the verbiage, right? It's gonna say like invalid PQ, and you're gonna be looking at just that line, but it has nothing to do with that line. Does that make sense?
They'll give you an alarm, and that shit's like all the way at the top, and you're like halfway through the program. And you're just
So,
like, we
trust
Yeah,
me.
it's a 3-line program.
Yeah.
We gotta make sure that we find it. So we have our N20, G00, G40, X3. So this is just rapiding, canceling your cutter comp, and going above the part. Remember, we left off at X2.8, so X3 inches is gonna take us above it, right? And then we have our G70, P10, Q20.
Code line.
The G70, guys, you don't use it all the time. What's one of the reasons why not?
It's
Like the way that they have it here, just on
Finish
it.
cycle.
What's one reason why you think that you wouldn't want to use it?
Because you might have to run that cycle again on the next part.
Because most of it, if you're doing several parts, you're just gonna be roughing them all anyway.
Oh, but that's a finish pass.
Right, that's for finishing, that's why you wouldn't use it, because you're roughing out
Well,
parts.
for one, obviously if it's like this, you're using your rougher as your finisher too.
Because
Right.
it already has the.
So you're not separating them.
You just
Right.
speed it up.
So if you're cutting stuff like Inconel, this is not the way to go.
Mm.
You want to have your rougher and you want to have your
It
finisher
must be plastic. man.
separated. If you're running plastic, aluminum, or something like that, maybe you could get away with this.
So you would put that because you have that U and that W there, right?
Yeah, with this, or even if you have the U or the W, you could write another program under it, give it a different tool number, give it a different intro, right? Then you give it the P and the Q, or the N70, and then the outro. So it would remember that. So it will still do what that is.
Oh, so it'll remember that from
But-
all the way at the top still.
Well, you're cutting it up here.
Yeah.
That's why. So it will call it up still, but under a different tool number. That's the more reasonable way to do it. Because that way, you could have a rougher and a finisher. Because once you dial in your finisher, you really don't want to mess with those numbers, right? Unless your machine, who in here has ran like a really old machine before? Damn, cuz y'all got brand new machines where you're at.
No one's gonna say.
Alright, I ran in some machines before. In the morning, you turn it on, you let it warm up for 20 minutes, you do your first part, it's dialed in. 3 hours later, your numbers start changing. Why? Because the machine warmed up, right? So it's not cutting, it's either not cutting as much as it was, or it's cutting more, because it's warmed up and it's going, right? You go to lunch, you come back, guess what? Machine's cold again. So now you're chasing your numbers again, right? Comes more into play whenever you're dealing with plus 5/10 of a thousandths minus 0, right? I mean, because when you got plus 5/10 of a thousandths minus 0, you got a stressful day, right? You're chasing it. And if you have it together, there's no way in hell. Especially with Inconel, you can't just change out an insert and say, well, I was dead on the money with this last insert. It's the same insert, but I just switched it corners, so it should be right on the money. No. Even though you just switched the corner, you're still gonna wanna raise it and baby it down to what you need it to. Does that make sense?
So that finishing cycle, that's basically just using all the same information.
Yeah, it's
You're just
the
running it
same
again,
geometry.
yeah.
Yeah.
But you would just switch
But,
tools.
yeah, like we left, but for the rougher though, we left 20 thousandths on the X, and we left 10 thousandths on the Z, right?
But that one isn't taking it off. But that
It
way-
takes it off because it knows that it's a G70.
Okay, so it's just gonna do that
So the
automatically.
G70 is automatically gonna clean up the finish, use it as a finish pass. You should've had a test on this, huh?
Mm.
Boy, I tell
Tomorrow.
you.
Oh, tomorrow we got Mazak.
And the next day I might have Rob. So, yeah.
Mazak does all that shit for you.
That'll be interesting.
Alright, so, y'all need a break or y'all wanna go straight up to the machine?
Break.
I already took the kids to the pool, so I'm good.
Alright, so let's go out to the machine. Corey, if you need a break, go ahead and take it. Alright.
Cool.